There are many different careers that use quadratic equations to model situations. For example, astronomers use quadratic equations to describe the orbits of planets, solar systems, and galaxies. Insurance agents use them to figure out the speeds of cars that have been involved in accidents. Quadratic expressions can be used by software developers to model animations for applications. By changing the parameters of the expression, they can create animated movement of a character. Let's see how one software developer used a quadratic expression to make a peanut jump over a wall. Consider the expression y equals negative 0.1 times x minus h squared plus k. It will be used to model the path of a character, an animated peanut jumping over a wall. Y represents the height of the peanut as a function of the horizontal distance it travels, x. The first trial of a jump used the equation y equals negative 0.1 times x minus 16 squared plus 7. Since it is in vertex form, we know that k is 7 and h is 16. The base of the wall is located at coordinate 22, 0, with the top of the wall located at coordinate 22, 4.5. The dashed curve shows the path of the peanut's jump. The peanut did not make it over the wall with these parameters. What changes can be made in the parameters of the equation in the first trial to successfully get the peanut over the wall? Let's use a tool that helps us dynamically see the changes in the jump as the parameters change. Shift the starting position of the peanut closer to the wall, translating the graph horizontally to the right. This can be done by making h a larger number. Let's use 22 for h. Because h is the x-coordinate of the highest point of the jump, if that point is directly over the wall and the k value remains at 7, then the peanut would clear the wall. So, the new equation would be y equals negative 0.1 times x minus 22 squared plus 7. Stay in the same starting position. Change the value of k, which is the vertical coordinate of the vertex, to 9, so that the vertex is at coordinate 16, 9. And there is still enough vertical distance to clear the 4.5 unit tall wall when x is 22. The new equation would be y equals negative 0.1 times x minus 16 squared plus 9.